Just give me a second. It will displacement. After that, I've completed the effects. Chicken next. Okay. So now let's discuss the lateral displacement. Let me tell you what is lateral displacement. So let me write down the definition first. After that, I'll explain the term. Chicken. Distance. Original path of incident ray. Emergent ray. Coming out of a glass slab is called lateral displacement of emergent ray. This is the definition. Now let's talk about the actual thing. Okay. Suppose that this is the glass slab. Okay. And the light ray is incident on this glass slab. Okay. So this is your, let's take suppose this is so next. This is your number. So everyone, where does the light ray will refract if it's going from air to glass? After refraction, where would the light ray will go? Yes, everyone. After refraction, where would the light ray will go? No one did revision?
It will bend.
Ritvika, right? Huh?
It will bend towards the normal.
Towards the number, because you are going from rarer to denser. Air is rarer, glass is denser. It will bend towards the normal. Okay? So it will bend. Just a second. Will bend just the normal light. Okay. So you can see this thing, everyone. The light is bending towards the normal. Actually, it should have gone straight, but due to the change in speed of light, it is bending towards the normal. Clear?
Yes, sir.
After that, what will happen when the light ray is going from air glass to air? Okay, so it is basically striking this glass at this point. This would be a normal. Okay, now where the light ray will go? To let me know which one.
It will bend away from.
Huh?
It will go away from.
Away from the normal. Very good. Afrin. It will go away from the normal. So we come out like this. Okay. So what you will observe is that, everyone, that if you extend this line, if you extend this line, okay, so I'm extending this line like this, right? So you can see this thing that if you extend the original path, so you can see this thing, both are parallel to each other. If the light after two times after the refraction two times, the emergent ray is parallel to the incident ray. Is that clear or not? Yes or no, Vijay? Yes or no, at least बच्चों कुछ तो बोलो.
Yes,
You can
sir.
see this thing, and this
Yes.
distance between the two lines, that is called the lateral displacement. What it is called? This is called the lateral displacement. See this. So that's what the definition is. The perpendicular distance between the original path of incident ray and the emergent ray. This line is called emergent. This is your incident ray. Okay, of the glass slab. That's called lateral displacement. Please do let me know, everyone, is that clear to you or not? Okay,
Yes, sir.
so let me write down. Okay, this is your angle of incidence. Okay, this is your angle of refraction. This is also angle of refraction, because see this thing, everyone, both normal are parallel to each other. So this is acting as a transversal. This is alternate pair of angles. Okay, and this angle is called angle of emergence. And for your information, everyone, this is a very important thing that I'm going to write. That is, angle of incidence is equals to angle of emergence. Please remember this thing. Angle of incidence is equals to angle of emergence. Okay?
Yes, sir.
Okay, please draw this thing.
Sir, I did not understand.
Which part, Safia?
That parallel and all.
Dekho, we know this thing that if two lines are parallel and if a transversal is cutting, so this angle and this angle will be equal to each other. Sorry, this not this one. This angle and this angle. Yes or no? Transversal, alternate pair of angles. So similarly, this angle and this angle, see this thing? This is parallel to this normal. So this line is acting as a transversal. This angle and this angle are equal. That's why it is both angle of refraction. Okay? incident ray. Merge. Okay. Achha, everyone, this line, the extended line should be drawn with a dash line like this. Hi, Umar, how are you? Why did you join late, Umar?
I joined the wrong link and I was waiting.
Ah, okay, chalo, no worries. Okay, we have just this thing. So basically, I was telling that when the light ray is going from air to glass, so after the refraction, Umar, the emergent ray and the incident ray will be parallel to each other, and this distance between them is called lateral displacement. Okay? Yeah. So this one is your air. And this one is your glass. Please do let me know everyone, is that clear to you or not?
Yes.
Yes.
Okay. It's a very important topic. The exam in the exam, it comes straightforward. Define lateral displacement, draw a ray diagram to show that the emergent ray is parallel to the incident ray of light. Okay, straightforward question for 3 marker. You have to write down the statement. Then after that, you have to draw the ray diagram, labeled one. Angle of incidence, angle of refraction, angle of emergence, everything should be completely labeled. Okay, clearly labeled. Clear, everyone?
Yes, sir.
Good. Okay, now let me know one thing, everyone. Okay.
Can you scroll up a bit?
Yes, Navid, Numair, are you saying something?
Yeah, can you scroll up a bit?
Sure, sure. Check. Note it down, no worries. Urgent ray. Right. Then, Numair?
Awesome.
Yeah.
That's
Okay, now let's one thing. So this is an important case. suppose there is one glass slab. Okay. So this is normal. Okay. So everyone, suppose the light ray is falling incident, basically, you can say the falling a 90-degree perpendicular to the glass slab. What will happen? Can anybody tell me? How does the light ray will travel from the mirror? Oh, sorry, from the glass slab.
It is straight line.
Straight line. That means it will go without refraction. Umar?
Yes, sir.
Okay. What about rest of you? Afrin, Ritika, Safia, Rayan?
So without reflection.
Without refraction, Rayan. What about you? Without you? Without just a second, everyone. Actually, I was thinking a little bit. Okay. Yeah. Rayan, you have given the answer. What about you, Ritvika? I don't know what
Sir, I
is
think it will take place without refraction.
cheekiest. Afrin.
Without refraction.
Cheeky. Cheeky. Safia.
Without reflection.
Reflection, ne? Refraction.
So I said refraction.
And then you said refraction. I heard like you said reflection. Okay. Yeah. So if the line is if the light ray is falling perpendicular, it will go without refraction. Okay. Just keep it like this. Okay. It will go without refraction. Let me write it down over here. Incident ray falls normally glass slab. Then there is no bending of ray of light. Straight. Put this down, everyone, fast. Then everyone.
Yes, sir.
Now let's talk about the next topic, that is your effects of refraction. Okay, now let's talk about the effects of refraction. So we see effects of refraction in our day-to-day life, like when you basically submerged pencil into the water, you will see that it will be bending. Let me show it to you. See this thing, the pencil is there in the water, but you can see after at the boundary of air and water, you can see this thing, the pencil is basically bending. Yes or no? It's not straight, it's bending. And it's looking a little bit more magnified as compared to the normal. Yes or no?
Yes, sir.
Stick, immersed, in water, appears to be bent. At the water surface. Is that clear to all of you?
Yes, sir.
Next is, if you basically place an object inside the water, it appears to be raised. Okay. Underwater, appears to be raised. Next is a pool of water uh, needs to be less steep than it actually then. Okay. So these are some your effects of refraction that we see in our day-to-day life. Please note it down. After that, we'll do some questions based on the refraction. Okay, everyone. So please answer in the chat in one go, like 33, 32, 33, 34, 35 till 38 in one message only. Okay? Do not use multiple messages. Just use one message to write down all your answers. Do it fast, everyone. Just give me a second. Please start. Umar, I'll share the, you can say do one thing. After this class, there will be a recording of this class in your account. Okay. From that, you can take the notes. Okay. I was saying you were asking me that where to have like from where you have to write the notes. So after this class will be completed, so you can go through and check. You can go and check out your account. There will be a recording of this class. So from that recording, you can note down your notes. Okay. Obliquely means at some angle, Umair. Some angle. Okay, making some angle obliquely. Okay, something like that. It would be. Okay, this is the normal. So it's making some angle. The angle could be anything, but it should be having some angle obliquely. Okay. After this class, everyone, there will be an assessment based on the refraction. Okay. So please go and check out this class after this.
Sir, can I see the 39th one?
Okay, Ritvika, do it fast, would you?
Sir,
Okay, so please cross-check your answer whether okay, and after that you have to tell me that how many answers you have got right. So light is traveling from denser to rarer medium along a normal to the boundary. What will happen? Light will refract away from the normal. Is refracted away from the normal. The B option is correct. Okay. Next one is a ray of light passes from glass to air. The angle of refraction will be more than the angle of incidence because the refraction, the light ray will go away from the normal. In this case, see this thing, I've written the angle of refraction is more than the angle of incidence because light is going from denser to rarer. So option B would be there. Next is angle of the ray of light is goes into the water, the angle of refraction. So it will be yes, Omar, yes.
The question number 32, along a normal means in the 90-degree, right?
Just a second. Oh, sorry, I didn't notice that. Yeah. Denser to the area. So it would be is not refracted. Sorry, my bad. I didn't notice that. I'm really sorry. Okay. Just a second. A ray of light is going into the air. The angle of refraction would be, it will be smaller than the angle of incidence because the light will be bending towards the normal. Next is speed of light. It's 3.8 into 10 to the power meter per second. Okay. Next is when a ray of light is traveling in glass, enters in water obliquely. So it's glass is a solid, so it will be more denser than water. So it will denser to rarer. So it will refract away from the normal. Okay. Next is a ray of light falls 90 degrees at right angles parallel. The ray of light will not refract at all because the light ray is falling at 90 degrees. There will be no refraction. Next is a light is passing from medium X to Y. No refraction happens. That means the angle, the basically angle made by the light is 90 degrees at Y. Clear, everyone? Now let's understand this case. Okay. So over here we have materials, right? So such kind of questions should be done in such manner, right? See this thing, water and air. Which one is denser? Which one is denser, water or air? Yes, everyone, answer. I'm asking from all of you.
Water, sir.
Water, no? Yeah. So I'm writing D. Okay. This will be rarer. Air, glass. Which one is air is rarer or denser?
Rare.
Rarer. This one would be denser. Glass or water? Which one is denser? Glass or water?
Glass.
Glass, because it's a solid. And this one would be rarer. Next one, glass or air? Which one is denser?
Glass. Air.
Denser. Glass would be denser, and air would be rarer. Water or glass? Which one is denser?
Glass.
So glass. This one is rarer. This one is denser. Okay. Now let's check it out. So light is going from denser to rarer. So how should the light ray should be? How does the light ray should behave? Away from the normal or towards the normal?
Away from.
Away. So here you can see this thing. Light is going towards the normal. That means this is the wrong diagram. Next one, rarer to denser. Where does the light ray should move? Towards or away? Towards, right? So it is going away. So that one is also wrong. Next one, glass or water, denser to rarer. Where should the light ray move? Away or not towards?
Away from.
Away. That, but still it is going towards, so it would be wrong. Next one, glass and air, denser to rarer. Which one? Denser to rarer. Where does the light ray should move? Away or towards?
Away
Away.
from.
Away from the normal, but it is moving towards the normal. That's why this is also wrong. This one, last one. Where does the light ray should move?
Towards.
Towards, yes or no? So yeah, it is going towards. So that means the E option is the right one. So please check your answers and let me know that how many of you have got the correct answers. How many numbers of answers? One by one. Rayan, how many answers you have got right?
Sir, 5.
5. What about you, Safia?
So 4.
For Afreen?
All are correct.
All?
Yes, sir.
Good. Ritvika?
Sir, I got 4.
Umair?
I got 2 wrong.
2 wrong. How many corrects? In total, I think it's 8 now. 3, 6, 7, 8. 8. 2 wrong. That means 6. You got 6 right. So Afreen got 8 out of 8. Umair got 6. Rayan got 5, I think. 5 now. And Safia and Ritvika both got 4. Okay. So is that clear? How to do such kind of questions if they appear in your exam?
Yes, sir.
Any doubt to anyone? Any doubt to anyone?
No, sir.
Sure.
No, sir.
Check it. Just give me a second. Okay. Now let's talk about the laws of refraction first. Okay. Laws of refraction. So, what is first law of refraction that says when the light, okay, so the incident ray writing pad is making troubles for me. The incident ray ray and normal all same plane. Okay. Next is the ratio incidence.
So what is after ratio of?
Sine, 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 sine. Is constant.
Hence, SINE.
Yeah. Pair of media. Okay. Clear, everyone? ठीक है, अब मैं इसको let me write it down. That is, so in the 10th standard, you will study sine theta, cos theta, trigonometric ratios in the maths. Okay, that's what it is, sine. So it's the full name is sine and written as SIN. In short form hota I means is the angle of sine. Okay. After that you have sine. The angle of R is equals to is constant. Okay. And this constant name is refractive index. Okay. And this law is called as Snell's law. Okay. This is also called as Snell's law. Is that clear? So if suppose that in the exam it comes out that what is Snell's law, so you have to write it. Okay. So this is what your Snell's clear, everyone?
Sir. So sin IO, sin R is always going to be the same number.
Yeah. If you take two mediums, any specific two mediums, like suppose your air and water, even if you change the angle of incidence, obviously refraction angle will change. But when you take the ratio of it, it would be constant. Okay. So they will adjust accordingly so that the ratio remains constant. That is not sin omega, that is sine I, sine R. Okay. Is that clear, everyone? Please note it down. The next class will discuss what is refractive index, how does it depend, and all the things, and we'll do the numericals based on that as well. So in this class, you have to go, after this class, you have to go and check out the assessment as well. Okay.
Finished it, sir.
Okay, that's great. Okay. So After this class, we'll be having the assessment. Okay, and we'll be sharing some questions as well. Just give me a second. Okay. Okay. So everyone, so with this, let's end this class. In the next class, we'll discuss more on the refractive index. Okay, what is refractive index? There are two types. We'll discuss it in detail. Okay, so then take care. Bye bye. Good night. Acha, I got what is one message that I got?
Excuse
Allah
me, sir.
Hafiz. Bye bye. Yes, Safia.
Sir, I have my exam on 12th, weekly.
Well, weekly. What is coming?
The till refractive index is coming for weekly test.
So refractive index will be completed by the next class.
Okay.
Ha.
And for my half yearly is on 26th May.
May. 26th May.
Yeah.
Acha, theek hai.
And my
What is
weekly is
coming
also
then?
27. 2 chapters are coming.
Mm-hmm.
And then I guess the second chapter is still half.
Which chapter it is? Human eye?
Yes, sir.
Half till what portion?
Till page number 164.
Check it. Page number 6. Okay, no worries,
Till
Safia.
defects of vision. Something.
Acha, check it. Check it. No worries. No worries. I'll basically inform the management regarding the same, so they'll schedule extra classes for you so that we can cover the syllabus on time. Okay. For the half yearly, because for the periodic test, this would be done in the next class itself. For the half yearly, that is on 26th May now.
Yes, sir.
Okay, we have 1 month. So okay, I think we need only 2 or 3 extra classes because within like for within the with like by your periodic test, this chapter would